Assalamu alaikum. Now we are going to start a new chapter which is relevant to the continuous probability distribution and particularly the normal probability distribution. In previous chapter we have studied the discrete probability distribution, which includes binomial probability distribution, hypergeometric probability distribution, and Poisson probability distribution. So in next slide we will discuss that what goals we have for this chapter. So we will understand the differentiation between discrete and continuous distribution. Then we will compute mean and standard deviation for the uniform distribution and compute the probabilities by using uniform distribution. Then we will enlist the characteristics of normal probability distribution. So as we have seen in the previous chapter that each and every form of probability we have used in for a discrete random variable, there was some certain characteristics or specific criterias for the application of a particular distribution. So next we will define and calculate the z values, and then we will see how to determine the probabilities between 2 points on a normal probability distribution, and then we will see that how a normal probability distribution to approximate the binomial distribution. In previous chapter, we have seen that how Poisson distribution approximates to the binomial distribution, where we have when we have n is greater than or equal to 20, or probability of success is less than 5%. So if we can say it in simple words that we have a large n and small probability of success. So that point where the binomial distribution is equal to Poisson probability distribution. Okay, now moving on to the next slide, where we will study that how uniform distribution will work. So uniform distribution is simplest distribution for a continuous random variable. Before moving on, let me define the continuous random variable, where we have a infinite number of values along an interval. So what is the difference between continuous and discrete probability distribution? In discrete probability distribution, where we only take certain values along an interval with possible values having gaps between them. But in continuous probability distribution, the random variable that are able to assume any of an infinite number of values along an interval. So that is the one difference between discrete and continuous random variable. This distribution is rectangular in a shape and is defined by the minimum and maximum values. So here we can see that we are finding the range basically. So if you remember that in chapter 2 we have studied the range formula, where we subtract the minimum values from maximum values, and we will get the range. So in continuous random variable, x can be an infinitely small intervals along a range. So that is the definition for the continuous random variable. Now we will discuss some characteristics for uniform probability distribution. It has the vertical coordinate, where we have seen there, this is the vertical coordinate and this is the horizontal coordinate. Here we have probability of x, or we can say it is a fx, or a function of x, which is also referred to as the probability density function. And here we have x values. So a is the minimum values, At B point, we have maximum value. And this is called the area under the curve. So here, why we have that flat line here? So f of x is constant in the uniform probability distribution because uh, it is distributed uniformly over the possible values of x. So so if I write the expression will like this: a is less than equal to x is less than equal to b. So area under the curve will always be equal to 1. So this area will be always equal to 1. So this is the continuous uniform distribution, a graphical view. So moving on to the next slide. I hope that you guys can understand. Let me tell you in a more journal way. If you recall the concept that area of rectangle, which is equal to base into height, base into height. So the base here is, so what is the range formula of range? Range is b minus a, maximum value minus minimum value. So the formula for base is equal to b minus a and height. So here we have height, which is equal to f of x. So if we put in the values in that formula, so what we will get? The area is equal to b minus a into f of x, and here a is area is equal to 1. So if we do a cross multiplication, if we divide b minus a both side, so we will get here b minus a and b minus a divided by b minus a. So it will be cancelled out. So here we have only left with probability density function. So we will get the f of x is equal to 1 divided by b minus a. So now you can understand where we get this. So where from we get this height for this rectangular. So you can see that the area, uh, the height of the area is uh, will be computed from 1 divided by b minus a. So I hope you will understand that how we get these formulas. So next we will move on to the next slide and see what we have next. So if I do it vice versa for the how we get the area for 1, so it we can do it as a area is equal to base into height. which is equal to b minus a, and 1 divided by b minus a. So these two will be cancel out, and we will get the area is equal to 1. So I hope that you will understand that how we got these formulas for rectangular. So it seems that my cursor is stuck. Wait for a second. Okay, and now we will move on to the next slide. So what we have in the next slide. So here we have some formulas to compute the mean and standard deviation for the uniform distribution. So for mean, we have here a plus b divided by 2. So it will be like a midpoint, and we will find out mu in that way. Next, we have standard deviation for the uniform distribution. So sigma is equal to under root b minus a whole square divided by 12, and then uniform distribution, which is p of x is equal to 1 divided by b minus a. Okay, so next we have the example relevant to the uniform distribution. So first, I will read the example and explain that what are the requirement to solve this question. Southwest Arizona State University provides bus services to the student while they are on campus. As bus arrive at North Main Street and College Drive stop every 30 minutes between 6 a.m. and 11 p.m. So here we have the information regarding of bus arrival in on the college stop between 6 a.m. and 11 p.m. for every 30 minutes. So during weekdays, students arrive at the bus stop at random times. The time that student wait is uniformly distributed from 0 to 30 minutes. So here we have the minimum value is 0 and maximum value is 30. So next we will draw the graph for this distribution. And then we will see how what will be the mean waiting time and standard deviation for the waiting time, and what is the in third part we will see the probability, what will be the probability of a student will wait more than 25 minutes, and in the fourth part we will see that probability of a student will wait between 10 to 20 minutes. So if you can see that here we have draw a area under the curve, which is started from 0 to 30. So here we have we have the time from 0 to 30, the length of the wait, because every after every 30 minutes that bus will arrive at the station. So next we will find out that what is the average time that a bus will arrive on the station. So we will find out the mu, a plus b divided by 2, which is equal to 15. So the central value or the mean value, which is equal to 55, and standard deviation. Standard deviation is basically the distance from the mean, which is 8.66. So these are the simple formulas for computation of mean and standard deviation for uniform distribution. We have studied and discussed a lot of time that what is mean and what is standard deviation. Mean uh, is a measure to find out the central location of the data, and the standard deviation is used for the dispersion or the distance. Okay, moving on to the next slide, where we will see that how to compute the probabilities for the uniform distribution. So here we will see what is the probability a student will wait more than 25 minutes. So here we will only find out the area where we have a chances that student will wait for 20 more than 25. It means that from 25 to 30 minutes. So we will find out here. You can see that the height of the area is not changed. Only the base is changed when we are changing the minimum and the maximum values. So just keep in mind by understanding the situation which is given in the question, that here they are asking only for the um, more than 25 minutes, not from 0 to 30 minutes. In previous situation, we have the student will wait from 0 to 30 minutes. But in this situation, there is only, uh, they are only considering those who are waited for more than 25 minutes. So this is the formula: probability of 25 minutes wait time greater less than 30. So height into base 1 divided by b minus a into b minus a. So in this situation, 25 is a and 30 is b. So in next slide, we will see that how what is the probability a student will wait between 10 to 20 minutes. So probability of 10 is less than equal to wait time is less than 20 is equal to height into base. So here we have a different situation around the mean. So 10 is a and 20 is b. I hope that you have noticed that height is not changed in any situation, but all the time base is changed during according to the certain situation. So here we are going to start with the characteristics of normal distribution. Previously, we have studied the uniform probability distribution. So both distributions are basically relevant to the family of continuous probability distribution. So here I'm going to start with the drawing a normal curve, and then we will discuss point by point. It is the bell-shaped and has a single peak at the center of distribution. So the distribution is a bell-shaped curve and have a one peak. Okay, you can see there is a one peak at the center of distribution. And at this point, mean, median, mode are equal. So mean, median, modes are equal at that point. The total area under the curve is 1. Half area under the normal curve is to the right of this central point, and other half is to the left of the central point. So it means that we have zero point 0.5, we have total area under the curve is 1, and it is symmetrical about mean. It means that we have both tails are equal from both sides. It is asymptotic to the line. It means that this line never touches to the curve. You can see the explanation here. The curve gets closer and closer to the axis. There we will have the x values here, but never actually touches it. To put it another way, the tails of the curve extend indefinitely in both directions. So here we will have negative infinity, and at this point we will have positive infinity. The location of a normal distribution is determined by the mu, and the dispersion of or the spread of the distribution is determined by the standard deviation. So here we will see the, as I have told you, that mean, median, mod are equal. So mean will be, or the location of a normal distribution will denote by the mu, and the spread or the dispersion will determine by the standard deviation. So we will see what we have in the next slide. So moving further, here is a normal distribution curve. So it's all relevant that I have described before. The normal curve has a symmetrical two halves, identical. It means that it is equal half on both sides. And when both tails are equal, it means that the curve is symmetrical and identical. Theoretically, curve extended to the negative infinity, and theoretically curve extends to the positive infinity, and at the middle point mean, median, mods are equal. So the normal distribution have its families. So if we can see that the standard deviation, if standard deviation vary in different situations, so the curve height will change. So this illustration, basically the first one, if you can see here, this one is, let me open the annotate tool so we can follow the graphs one by one. So in this illustration, we have a normal distribution with equal mean but different standard deviations. So here we have seen that there are three curves but having a same mean which is equal to 20, but the standard deviation is different for every curve. So here we have standard deviation for 3.1 years, then 3.9 years, then 5 years. So it means if the standard deviation changes, the height of the peak of curve will be changed. In next diagram, if you can see that the situation is the normal probability distribution having different means but equal standard deviation. Sorry, not this one. Actually, this one have a different means, 283, 301, and 325. So these means are different and a similar standard deviation. If you can see, the peak of every standard deviation is same. And in this curve, we are seeing that every graph is changing according to its mean and standard deviation. So in next lecture, we will discuss the standard normal distribution. For today, we are ending our lecture here. Thank you so much for your time. Allah Hafiz.